In this example, I just wanted to discuss the congruence classes modulo n a little bit more. So the congruence classes, remember, are the sets, so they're written like this. So let's say, just for example, I'll make an example here. The congruence class of 2 modulo 5, right? This is the set of all the numbers whose remainder is 2 when divided by 5. So let's start in the middle here. 2 is obviously one of them, right? It's the representative that we use to define the class. 7 is one of them, 12 is one of them, 17, etc. Right? But also we can go in the negative direction. So negative 3 has a remainder of 2 when divided by 5. This means when using the division algorithm, right? When using the division algorithm to divide by 5. And then back here, how far can we go? We have minus 8, right? And then minus 13, etc. So this is an entire set of representatives, right? Now, the only congruence classes modulo 5 are 0, mod 5, right? So this set right here, this set of the congruence classes themselves, 0, 1, the set of 2 that we just wrote out, right? 3, and then 4, right? Those are the only ones. So these are the only congruence classes modulo 5. And so this is now, it's a set of sets in some sense, but we've proved and we've studied, right, that modular arithmetic works, right? So if you add together 2 of these classes, you get, so like the class 4 plus 2 gives you the class 1. There are different ways that we can use we can do arithmetic and algebra on this set of congruence classes. So we can reduce every number to its congruence class and then perform operations on the congruence classes. Now, this is obviously going to be really similar to, I'll use this symbol, we haven't defined this, but this is just going to be similar to the space that we called Z5, right? So remember, the space Z5 is just the set of natural numbers that are less than or equal to less than 5, sorry, strictly less than 5. So 0, 1, 2, 3, and 4. And you can see the relationship here because each of these elements, right, corresponds to the representative element of a congruence class, or the remainder when divided by 5. All right? So this is just another notation that we can use to identify the congruence classes. So the space of all congruence classes. That space, by the way, is called the Moduli Space of, degree n or size n or whatever you want to call it. But we are going to use this notation a lot moving forward. Okay, so this notation is very valuable to us when we are doing modular arithmetic. So, for example, if we said 17 is congruent to 2 mod 5, right? This 17 is not a member of Z5, that's fine, but it is a member of a congruence class, right? The same congruence class 2 mod 5 over here, and that's where this symbol that looks like an equivalence symbol, right? But we call it congruence. This symbol right here then just tells you what is this statement saying? It's saying that these are both members of this set, and therefore that they may be regarded as part of the single element of this moduli space, if you wish. Okay? So again, this is just a brief video on some notation that we're going to use, but the idea of congruence classes as being single elements in a larger set, or a larger space you might say, called the moduli space, is going to be very important and very useful moving forward. So we'll leave it there, but you will see this notation moving forward.